Alright, so we want to measure the slope of the tangent line at that point. But to find the slope, we normally need 2 points, right? So, fine. We have a point x, and we'll draw a secant line instead to get a second point. So that second point will be h away from x, so x plus h. And so to find our slope, we're going to need y values too. Now this is f of x, right? That's the y value when at point x. And similarly, this is f of x plus h, the y value at x plus h. So when you're finding the slope, right, your slope is your change in y over your change in x, your rise over your run. So the change in y is f of x plus h minus f of x, that's the change in y, and then the change in x is x plus h minus x, or just h, right, because it's h away, so x minus x gives you h. That's your slope, and we want that value, that h, to get really, really small, because the closer h is to the original point, the better it approximates the tangent line. So we're going to let the limit go to 0. So that's the formula for your derivative, for your slope, f of x plus h minus f of x, all h, limit as h goes to 0. This formula used to scare the bejesus out of me, but it makes so much sense if you just break it down. Find your slope every time, change in y over change in x, rise over run. Keep it straight and you'll be fine.